Hi there. In this video, we will try to learn that how we can do the cost-benefit analysis in the presence of uncertainty. We are going to consider an example in which we will be developing a game, and that game will allow us to analyze the situation. And we will come up with not just net benefits, rather expected net benefits. So let's unravel these jargons one by one. Primarily, what we face as a cost-benefit analyst is the unpredictability of the future, and we have to try to predict it. So this is what we do in cost benefit analysis in face of uncertainty. Since we are mere mortals and we are rarely able to precisely predict the future, but we still try given the faculties that we have. And in many situations, the circumstances, they are usually beyond the control of us, that is the clients and the analysts. For example, we remember that COVID-19 was a pandemic, and even the endemics and epidemics, they are not within our control. The floods, bumper crops, or other fluctuations, for example, in the international oil prices. These are all exogenous factors that we cannot precisely predict. So this is the cluster of reasons that cause uncertainty and cause a challenge to us, that is the cost-benefit analysis. Now, being the analyst, how we can reasonably take into account the uncertainties. So we have to acknowledge before we go ahead that it will be an imperfect attempt, but we will do it and it is worth it. In this process, we will learn about two things. In this video, we will focus on the expected value analysis, and in the next one, we will also learn that how we can find out the value of information. So let's focus on expected value. It is basically the dependence of the cost and benefits on the occurrence of the specific contingencies, which in other words are the states of the word. For example, will it rain or not? These are two different states of the word, and the benefits and the costs of a certain intervention can depend on these contingencies or the states of the word, to which the analysts are able to assign probabilities of the occurrences. So will it rain or will it not rain? If it is cloudy, we can say that the probability of having rain will be greater than 0.5. That is, there are more chances of having rain. So we can assign the probabilities to find out the likeliness of a certain event. And in the next video, we'll focus on the value of information. And in that, the analysts have the opportunity for gaining additional information about the costs and the benefits. So that additional information is the key question. And we have to find that, is it worthwhile to get this additional information? Because if we get this additional information, it might require some expenditure. And that cost will be compared with the value of information that we will get. So this is why we have to do the comparison of the cost of getting the information and the value of information that it generates. And we try to explicitly model these things. Now let's focus on this topic, which is the main topic of this video, and this is the expected value analysis. In the expected value analysis, we have to confess that there is inability to specify the full range of the relevant circumstances that may occur. And we can try, but we are uncertain that what will happen. For example, if it rains or if it not rains, there might be another possibility. There can be an earthquake, or there can be a storm in which there is no rain. So there can be unexpected events as well. This is a very limited situation in which it might rain or it might not rain. There might be a windstorm without any rain. But in our other projects, there can be a variety of issues. For example, if in an infrastructural project, we have many possibilities they are there of various events that can happen. For example, there can be some war, there can be some natural calamity, there can be scarcity of some integral input, and there can be decline in the demand of that certain infrastructural project services that can be given to the people. People may shift to that some other alternative. There can be new technology allowing the people to travel in a different way instead of this infrastructural project facilities. So there are many events that can happen. So it's not very much likely that we will be able to assess all the possibilities in an exhaustive way. Then we have the human and natural world that are so complex, and we cannot totally anticipate every future event. This is already understood with the help of some scenarios that I highlighted. Still, we try to have a number of distinct contingencies, and we can list them so that our analysis gets wholesome. And for example, deciding whether to take an umbrella to work, it has two contingencies: either it will rain or it will not rain. But even though we think that this is the exhaustive list of possibilities or contingencies, there can be another possibility which is unexpected, that someone might try to mug us, and for that we can use that umbrella as a weapon for our self-defense. So this is an unexpected contingency that is overlooked in our analysis. This is why in this very simple possibility, there are possibilities of having unexpected events and hence unexpected states of nature. Still, we try our best to list down all the possibilities. Now, in the next step, we assign the probabilities to these occurrences, and this will help us to use these probabilities to assess the likeliness of those events. And that uncertainty can be attempted to measure to a certain extent, because fully we cannot measure the uncertainty. Now, simple situations, if we have such situations, risk can be readily incorporated into CVA through expected value analysis. So this is the utility of using the expected value analysis, that we can include the risk in our analysis, which is a very useful thing in decision making. Everyone wants to avoid the risk and the consequences of it, no matter it is public sector or private sector, or if it is an individual. Now let's talk about these contingencies and their probabilities in further detail. The modeling of the uncertainty as risk begins with the specification of a set of contingencies. So these are the contingencies that we develop in order to assess the risk, and in that we can come up with some set of contingencies in which we have the nature of exhaustiveness and mutually exclusiveness. It means that we should try to list all the possibilities should be included, and the possibilities should be mutually exclusive, that they should not include the other possibilities or intermingle these possibilities in an overlapping manner. So they should be mutually exclusive. If one is happening, the other should not happen. If these two properties are there in the list of contingencies, it is a good list of contingencies. Can be thought of the possible events, outcomes, or the states of the world. These contingencies can be put into different words, as we have seen here: possible events or some outcomes, etc. And only one of the relevant set of possibilities will actually occur. Definitely, if it rains, then it will not be the situation where it doesn't rain. Or if it doesn't rain, then rain cannot happen. So these are mutually exclusive outcomes or contingencies, or the states of nature. Now we have a numerical and symbolic depiction of these contingencies. We know that the sum of the probabilities is equal to 1, and we have the contingencies. 3 of them we have considered here: C1, C2, and C3. And we have to assign them corresponding probabilities, that what is the probability of having the state of nature C1, what is the probability of having the state of nature C2, and what is the probability of having the third contingency. And definitely the sum of these probabilities will be equal to 1. And how we can devise these probabilities? They can be based on historically observed frequencies, or some subjective assessment can also be made by the analyst or the clients. And there can be other experts as well who can allow us to have these probabilities. For example, the National Weather Service is one of those set of experts who can tell us about the probability of having rain or not, or having any flood or any other windstorm. So we see we can gather all the information that we can get from the past, the historically observed frequencies, and on the basis of that we can make some subjective assessments, and we can also consult the experts for that. So we should get all the information that we can, and then we can try to convert them into probabilities for the calculations. Talking about the calculation, it is very easy, because once we specify the contingencies and their respective probabilities, we will be able to come up with an expected net benefits value, which can be further used for some decision making. It is basically the weighted average of the net benefits over all the contingencies. It means that we have to incorporate all the contingencies and their probabilities, and the probabilities will be used as the weights in this weighted average. If we assume that there is n number of contingencies and we have the benefits, and I basically shows the events that can happen, and B is showing the benefits, and the C is representing the costs. So probabilities, they are also there. I is again showing the contingency, and finally we can convert it into a formula. This is the symbol that we can use for expected value of net benefits, and here we are. This is the formula, expected value of net benefits is equal to P1 into B1 minus C1 plus P2 B2 minus C2 up to a certain set of values, and then Pn into the net benefits of the nth contingency. So this is the first contingency, second, third, and the final one. These are the net benefits in the first contingency, and so on. And this is the probability of the first contingency, probability of second contingency, and of the third contingency. So you see that probability is being used as a weights of these net benefits, and then definitely we are adding them. In the denominator there will be 1 because the sum of all the weights, that is the probabilities, will be equal to 1. Now let us convert this general formula into an example. If we assume that an outdoor concert is being arranged, and there are definitely two broader possibilities that it might rain or not, then we can try to calculate the expected value of holding the concerts outdoor. Here we are, the value of the rain probability and definitely the probability of no rain probability. Both of these values, they are given. If the no rain probability is 0.5, rain probability will be 0.5 as well. And if we consider the possibility of no rain, the concert will be a success and it will have this much of the return. But if it rains, the environment outdoors will not be suitable anymore and there will be a loss of this much. So for the expected value, we can take the weighted average, and we have done it here. This is the value for no rain and this is the value for rain. This is the probability getting used as the weighted average weight, and here this is the other weight. Putting the values, so simplifying, we get the expected value of holding the concert outdoor. It is considered as the expected value or the expected profits, specifically speaking. Now the interpretation is an interesting thing. Here we see that this is the value which is a positive value, so it gives a good signal to us because it is positive. But we say with caution that may be undertaken because this is not the value of certainty. This is the value which is expected one. Now instead of this 5,000 or minus $500, that is this profit or this loss, this value is being calculated. But in real life, either we will have this benefit or this loss. So how this value is useful? It is useful because primarily it is positive, and it shows that if this event is held again and again, sometimes it will rain and there will be loss, and sometimes there will be no rain. So in this situation, there will be an overall value, an average value, which will tell us that if this event happens repeatedly, then on average, what will be the outcome? On average, the outcome will be desirable because the expected value is positive. So it gives us only a signal or likeliness that what is that we should go for. It doesn't give us the actual value because the actual value is this loss or this profit. But still, it has enabled us to reduce the uncertainty to a good extent, and also the risk is also reduced to a certain extent because now we know that the chances of loss are less when it comes to the net benefits. When we are facing a situation with complicated risk problems, we can model this into game against nature. So this was a very simple example, but there are possibilities where we have a complicated situation. And for that, again, we can use the expected value tool, and let us see how we can use that. A game against nature will be there because in this game or in this analysis, we are considering the external events of the nature, that how the nature is going to treat us, and then we will take certain actions to avoid any undesirable outcomes, and this is how it becomes a game against nature because the other party is the nature. The game against nature, it requires that the nature should be considered as a randomly acting agent, and that randomly acting agent is definitely because the weather can change without any dependence on us. It will rain if it is required to rain as per the nature decides, and our actions, they do not affect the actions by the nature. So it's a game against nature in which nature is non-strategic. It is not taking any action in response of our actions, and we will consider various states of the world. So let's focus on this example. So these two lines, you can pause the video and read them because they are already explained in words. Now we come to the events, the elements of the game against the nature. It will have various states of nature, and there will be probabilities of the occurrence of these states of nature, and there will be actions taken by the decision makers who are facing the nature, and there will be payoffs consequently, and decision makers, they will be able to make the decisions, and there will be combinations of the state of nature and the actions that we take. So from one side, nature is giving us various states of the nature, and we in response are taking various actions. So it becomes a cross-cutting matrix. As we know that a matrix is already giving us a table with cross-cutting phenomenon, and we will see that nature states, they will be listed in the table, the matrix, and the actions will also be there. So the consideration is of a planetary defense system, because there are concerns that an asteroid might collide the world, that is the globe, and we have to take various actions depending upon the probabilities and other variables. So this game against the nature will include the expected values of the asteroid defense alternatives that we will go for. There are basically three alternatives that we can go for. We can make a forward-based asteroid defense system. A kind of system will be in above the Earth, not close to it, far maybe into some part of the space, and it will defend the Earth from any asteroid. And it might use some nuclear weapon to destroy the asteroid if it comes towards the Earth. We can also go for a near-Earth asteroid defense system, in which we are not going any far in the future to build some sort of defense system. It is close to the Earth, and it is again targeting any asteroid that might come towards the Earth. And the final possibility is to have no asteroid defense system, because we are not making any precautionary setup. So vertically, these actions are listed. When we consider the horizontal dimension, these are the various states of nature that are beyond our control, definitely, whereas the defense system alternatives that we had, they were within our control, because we can make these defense systems. And the three possibilities are that we have a large meteor or asteroid hitting Earth, and that large meteor or asteroid would be having a diameter which is greater than 1 kilometer. Then there will be a slightly smaller asteroid, and that can hit Earth, and its diameter is between 20 meter and 1 kilometer. So we can call this as a medium-sized asteroid. And the final option is that we are not getting hit by any large meteor, and if there is a meteor, it is less than 20 meter. It can be a very small one, or it can be up to 20 meters. So this cannot become a headline. This can be a small news, and this is not a major concern, because the diameter is less than 20 meters. Now the probabilities of the states of nature, they are also listed, and these are the probabilities over the next century. So this possibility of having a large meteor is a very rare possibility. This is why we are assessing the value over the next century. So the first probability is of having a large diameter asteroid, and the probability is very low, that is 0.001. The probability of having a medium size asteroid is also less, but the probability of having no exposure to a large meteor is high, because usually this is something that we observe in our surroundings, that no large asteroid hits on a regular basis or without large intervals. It may happen in centuries, but not on regular basis. But definitely it's a big threat to humanity and the global economy. This is why we have to develop a way to assess the situation. So these are the different probabilities. Now the payoffs related to these states of nature, they are in US 2000 billions of the dollars. Let us see that how we can assess these. This is the payoff when there is a large asteroid, and we are opting for forward-based defense system. So this is the red color, which is showing the state of nature. This is the green color, which is showing the action taken. So this action stands true for all of these values in this row. So FBD, FBD. Here again, near Earth asteroid defense system, NED, NED, and NED. Here no defense system, ND, ND, ND. So in the rows we have the actions that we take, and in the columns we have these states of nature, LKM, LKM, LKM. These are all showing the large asteroid, and again BTW, BTW, they are showing the between large and a small meteor possibility. NEX is showing the no exposure to a large asteroid. So this becomes a matrix fulfilling the formality of a cross-cutting situation with rows and columns. So this payoff has a certain probability, and that probability is 0.001. So we multiply it with it. Here symbolically, the probability of this situation with large asteroid hitting the Earth with this probability, and we are undertaking the forward-based asteroid defense system. It should be added into the situation with medium size asteroid and the probability of the same, and then the no exposure to a large asteroid, then its probability. So see, it is the expected value that we are calculating here, plus this value and that value. All the three events have been summarized in it. So this is the product of the first term, the second term, and the third term. We add them and we get the expected value of FBD, that is forward-based defense system. Then the expected value for the near-Earth defense system, it is also found by using the same formula of expected value, but now we have the NED in our consideration, that is no near-Earth defense system. This will be the value after calculation. This is no defense system situation. This is the formula, the weighted average, and then we get the expected value. These are the numerical values that we will solve in this process. So we have three expected values, and all of these are basically the net costs, which means that these are undesirable values, and we should choose the one which is the least, and this one is the least. So the situation of the near-Earth asteroid defense system is suitable. This is the action we should go for because it reduces the net cost as compared to the other two actions. So this is the decision that one should go for near-Earth asteroid defense system as it minimizes the expected net cost. These are a few explaining paragraphs, and a few things we can see in this process is that if there is a large meteor, then there can be regional or even global effects, and the intensity of the earthquake caused by it can be 10 or more on the scale. And the exposure of the Earth to collision with a smaller than 1 kilometer but larger than 20 meter in diameter asteroid can cause severe local or regional effects and can cause this much of the earthquake or vibration on the Torino scale. And the third possibility is having a smaller asteroid hitting the Earth. So these three states of the nature are explained here, as we have already seen in the table. Here the three actions have been explained that we have already understood. And then we have this caveat, and that is the process that we are trying to do in this game against nature and defense against the asteroid is basically a very monumental work. It's not a small activity to do. And it can also become controversial because of the variety of the values that can exist, the uncertainty that can exist. If you look at the range of the payoffs, you can see that the least of the payoff is 0 and the highest is 30 trillion. So in this case, actually the least hazardous state of nature is happening. We go back to the table and see that this is that possibility that there is no exposure to a large asteroid, and at the same time we have not taken any defense measure. So it is a 0 because neither we are spending any amount nor any major asteroid is hitting the Earth. So the cost is 0. The highest value that we can consider is this, that is 30 trillion, because you can see that there is no asteroid defense system here and we are hit by a large asteroid, which means that there will be maximum loss. So this is the range that we can observe in this whole situation. There was least defense here, again least defense, that is no defense, but in this case no major asteroid hit the Earth, and in this case the worst state of nature, that is a large meteor or asteroid, hit the Earth. Another problem that might arise is that in our calculations we are assuming that there are three possibilities, but within these possibilities there is a lot of variety, because if we consider the size of the meteor, it cannot be just of three categories, large, medium or small. It can have various sizes or volumes, due to which it can have different effects on the Earth. So it means that we should consider all the volumes of or the sizes of the asteroid in order to be able to precisely determine the overall effect of the meteor or the asteroid. So this brings a lot of possibilities here, and hence the probabilities. Also, the composition of the asteroid matters, that how much of it is a solid one, is more of it a metallic part or otherwise. So that will also change the effect on the land, and that can also be another variety of possibilities, due to which our three possibilities, they seem very much limited. So the composition of the asteroid can also be a factor in determining the damage that it does, and the point of impact that it makes. That is, if it lands in the sea, definitely not much of the harm will be done. But if it lands in a well-populated area, it can really do a lot of damage, and many lives can be lost. So these are various possibilities that we didn't consider in our analysis. And this is why this is a compromise that we have done, because still it is a very cumbersome exercise that we are doing in this three set of possibilities. We can also see that $30 trillion is actually the half of the world's GDP in some past estimate. So it means that a very large devastation is expected in this case. And in this table, we have all those expected values that we calculated. And the expected values are basically the weighted averages that we have calculated, and probabilities are used to take the weight and average. Now, this is the expected value of no defense system. This is the formula. We have already understood it above in the table. This is a separate calculation that you can understand by pausing the video. And this is how we do this calculation. Finally, the conclusion is simple, that we are focusing on the expected value of net cost. So it should be minimized. It is not the net benefit of the expected value of the net benefits that can be maximized. So let's choose the lowest value. This is the lowest value. So it is desirable to go for this alternative. So this enables us to take a decision and go for a near Earth defense system. And this was the explanation of it, one of the calculations of those expected values that we did, a little bit of explanation, comparison, and how the game against nature was developed with three actions or states of nature. This was the table that we developed to understand this game against nature. And this is the set of the components of a state of a game against nature. And this was an example that we did to understand this concept of expected value. This is a general formula, and this is basically built to calculate the expected value, and these are the desirable properties of contingencies and probabilities, that they should be exhaustive and they should also be mutually exclusive. And finally, this was the example of the expected value analysis, and we did not go into the details of value of information, but in our next video we'll go into that detail. So this was the game against nature, in which we found the expected value of net benefits or net costs, as the case may be. Here there were net costs. In the next video we will do the assessment of the value of information. Thank you.